All right, so I'm going to change the subject now. Any other questions on regression? Okay, what I'll do next week, the last little bit that I want to talk about this is I want to just show you, get an example of how you do a regression where you have two independent variables. So we'll probably look at temperature plus humidity and how they work together to predict bike rentals. But that's a story for next week. So I now want to move on to a bit more about MCDM. So a lot of what I'm going to talk about here, it's a kind of mix of stuff that I've learned from practice over the years with MCDM. And it's also stuff that I'm including because next week we start talking in earnest about measurement. And I just want to tidy up some stuff about the measurement aspects of MCDM. So, all right, so let's, I think most of what I've got to say here about measurements will make a fair bit of sense. And, but I do need to talk about comparative judgment. So students who were in the tutorials last week will be familiar with that, I think, but, and perhaps those who watch the anyway, I'll go over it again. Okay, so when we're setting up MCDM, we do 4 measurements essentially. So 2 of them are fairly straightforward, but they're not things that we normally necessarily think of as measurement because they are categorical measurements. They're putting things into categories. So the first one is we choose the alternatives. In this case here, it's 5 projects. The ones that are in our consideration set, they're the ones that we are going to actually make a decision about. And then we categorize every other possible project as not in the consideration set. And that could include things that we haven't even thought of. There might be wonderful projects that nobody thought of, and so they're not in our consideration set. But if we did know about them, they would be, you know, we might have categorized them one way or another. And then we do the same thing with our set of consequences. So there can be lots of different consequences. As a practical matter, somehow or other, we do a categorization where we just choose the ones, 7 here, that we're actually going to consider, and the others just get categorized as not for consideration. So that's a kind of categorical measurement. The important thing to remember, that I really want you to remember after this course, is, you know, they should be conscious and careful decisions. You should be mindful of how you go about deciding what things to consider and what not to consider. And an important one with the alternatives is, in some situations, it's a very good idea to have an alternative which is do nothing. Okay. And that alternative is sometimes not thought about. So that's a categorical process, and we'll talk a bit in a moment about some of the ways you can go about that measurement process in practice. So, and there are situations where you have to do this kind of decision-making procedure, and somebody has already told you, usually somebody above you in the organization or to the side of you in the organization has already decided, you know, in this case, what projects are going to be considered and or what the objectives or criteria consequences are. So a lot of companies, for the particular example of project selection, a lot of companies have a standard set of criteria for choosing projects, and they often include things like the return on investment measured in various ways, and so on. Now, then you get the weightings. So these are measurements of decision-maker preferences. That's beliefs about the relative importance of the consequences. And they are, in MCDM, they are quantitative. They need to be quantitative. And the most common way that they're determined is by some sort of rating process. And ratings generally, at best, will produce interval level measurements, which are quantitative. Now, you may have noticed that I keep saying that things are at best interval level, or are at best ordinal level. And that's because there is this big issue with some kinds of measurement where we're not guaranteed as to what the level of measurement will be. And this is something we'll dig down into starting next week, but it's a very important takeaway from this course. It's a very important part of critical thinking about measurements used as evidence, that you think about whether the level of measurement is appropriate and how confident you are that the proper level of measurement has been achieved. So ratings can be done very well, they can be done very badly. But the best case you're going to get from ratings under most circumstances is going to be interval level measurements. Now you can use this AHP comparative judgment technique, which we used in the tutorial exercise last week, and that it is claimed and not generally challenged that produces ratio level measurement, but it has to be done properly to achieve that, and I'll talk a little bit later about what it means to do it properly. Quite commonly we express these weightings as percentages, and that makes sense for a number of the different types of decision rules that get used with MCDM. And as most of you seem to know from based on marking the exam, we don't have weightings that are equal to 0, because a weighting of 0 means that the consequences of no importance. So why would you have it in your MCDM matrix? Then we carry out this series of measurements for each consequence for each alternative. And so these are measurements of the likely causal consequences for choosing each alternative. They need to be quantitative as well, and they are typically determined by ratings. Again, in which case the best you're going to get is interval level measures, or ideally by comparative judgment, which would lead to ratio level measurements. But as we will see, comparative judgment has some practical limitations. So comparative judgment would be the preferred method of measuring these preferences and beliefs about consequences, and also for your weightings. But it's got one big limitation. It's got some other practical limitations. So you've got to explain to people what it is and why you're doing it. And, you know, depending who your audience is, if you've got a group of decision makers and they're very impatient and they're not very interested in the process, they might not be very happy about you inflicting this complicated looking method on them. But even if you're in charge of things and you can decide what methods are used, the practical limitation is to do with the fact that comparative and judgment involves you. Let's think about, say, the projects up here. There's 5 of them. You've got to compare each project with every other project, and that's quite a lot of comparisons. There's a formula for working it out, which is here. So in that case, it would be 5 squared, which is 25, minus 5, which is 20, divided by 2, which is 10. So you've got 10 comparisons to do for the projects, and you've got 7 objectives in that MCDM matrix. So there you've got 7 squared, which is 49, minus 7, which is 42, divided by 2, which is 21 comparisons. And as I will show you in a moment, you have to make those comparisons in a way that's consistent, which can start to get pretty hard to do. That number goes up pretty rapidly. So I've given you the number of comparisons here. You know, it's easy if you've got 2, you only need to make 1 comparison. But if you get up to 12 projects, for example, you'd have to make 66 comparisons, which is beyond the ability of most people. Roughly the upper limit is about 8. Once you get much above 8, you've probably got to use some sort of a technique or trick to get around that. I've known people who can actually do 28 comparisons with comparative judgment and do it really well the first time. Most people can't. I put a little chart there that sort of shows you how it starts to go off the scale. By the time you get up to 50 projects, you're looking at, I don't know, something like 1,500 or so comparisons, which is just impossible. Okay, so next week I'll show you this hierarchy technique, which in some situations can help solve that problem. All right, so how does this work? The method I'm showing you, this is the one that is associated with the analytic hierarchy process, which is a big deal in decision making. It's been around now since sometime, I think, in the early 1970s. There are many books written about it. There's at least one, I think maybe 4 academic journals devoted to it. It's been used for huge decisions, billion-dollar, multi-billion-dollar decisions. It's taken very seriously. Comparative judgment is a part of it. It's a distinctive part of the analytic hierarchy process. You know, it's not too hard to use in practical situations. So let's have a look at it. I'm going to begin with a toy example. And this is the toy example that I used in the tutorial last week. But I know that, I mean, the last week and a half has been a disaster for many people, and not many people made it to the tutorial. So let me go over this one again. Okay, so this is a toy example. I'm comparing my preferences for after dinner sweets. Okay, so the 3 things I'm comparing are ice cream, a type of fruit called a durian, which is famous for emptying out the ANU library a couple of years ago, and chocolate. So I've only got 3 things. If we use our little formula there, we work out there's only 3 comparisons to make. 3 comparisons is pretty easy to handle. Okay, so the 3 things we're going to compare are ice cream versus durian, ice cream versus chocolate, and durian versus chocolate. That covers all the possibilities for pairwise comparisons. And these comparisons are made using a judgment scale of intensity of relative importance. Now, there's a number of versions of this scale. It's been translated into many, many languages. But the one we're going to use is what I regard as the kind of pretty standard one. The guy who invented this thing published this version of it in an article in 2008. And he hasn't really changed it over the years to any great extent. The formatting of it changes a bit, so on, and the language, but this is essentially it. So what we do, let's look at our 3 comparisons. So let's say if it's ice cream versus durian, let's say I strongly prefer durian over ice cream. Now, so what we do is we look here for strong, okay, strongly favoring one thing over another. So he talks about activities here, but it can be anything. It doesn't have to be an activity. Okay, strongly prefer gets an intensity rating of 5. But what's happening here is I'm not saying I prefer ice cream over durian. I'm saying I prefer durian over ice cream. So the number I use is not actually 5, it's 1 over 5. So if we go back up here to the spreadsheet, I'm going to put in ice cream versus durian in that little cell there. I'm going to put 1 over 5, which is 0.2. So what I might do is get up the actual spreadsheet here. Let me just take it back to its native state. So all I do is I put in 1/5. Okay, and so that's taken. What that is saying is my preference for ice cream is 1/5 of my preference for durian, or my preference for durian is 5 times my preference for ice cream. And you'll actually see that it's grayed out here because it's automatically handled by the code in the spreadsheet. If I look at durian versus ice cream there, at that cell there, you can see that says 5. Okay, so durian I prefer 5 times more than, my preference for durian is 5 times my preference for ice cream. That's how you interpret it. Everyone with me so far? Let's push on. Okay, so the next one is ice cream versus chocolate. So in this case, I say chocolate is more than strongly preferred over ice cream, but not very strongly preferred. So if we go back and look at the scale here, we'll see that there's an intermediate thing here, which he calls strong plus. So that's between strong importance and very strong importance, and that gets an intensity rating of 6. So the same story here. This is chocolate versus ice cream, not ice cream versus chocolate. So in the spreadsheet, what I am going to put there is 1/6. Okay. And so that will now tell me, if I compare chocolate with ice cream, which is that cell there, it puts in 6. And up here I've got 0.17, which is 1/6. And then the final one I have to take care of is the durian versus chocolate. So what I say here is durian is weakly slightly preferred over chocolate. So weakly or slight is an intensity of 2. So in this case, it's durian is slightly preferred over chocolate. So I put the 2 there, not 1/2. Okay, so that's what we get. Now, there's 2 things we get out of this that we've got to be interested in. So one is the actual results we're after. So that's called a score here. So this is our weightings. And the second thing, so if we were doing this with consequences or, or preferences rather, for an MCDM matrix, this is where we would get the answer, and we would copy it out of here and paste it into our MCDM matrix. But the other thing we look for is this number here, which is called the consistency ratio. And what the consistency ratio does is it tells us how consistent our set of preferences is. So now the way this works in practice is you do your ratings, you'd work out your scores and put them in the spreadsheet, intensity scores, put them in the spreadsheet, and then hopefully you'll get a number which is less than 0.1. 0.1 is the threshold for acceptably consistent or not acceptably consistent. If your ratings are not acceptably consistent, then your scores, your weightings, these things are not going to be, or may not be sufficiently accurate. They may not be ratio level, they may not be sufficiently accurate. So if that happens, you've got to go back and have a look and figure out what's going on. So I've done here, what I've put here is another set of ratings for somebody with very different preferences. So this is somebody who moderately prefers ice cream over durian and moderately prefers ice cream over chocolate, but moderately prefers chocolate over durian. And you'll see the consistency ratio there has jumped up to 0.12. So that's a problem, and that needs to be resolved. Now, the thing to do when this happens is avoid the temptation to just sort of, fiddle with the numbers until you get the consistency relationship ratio below 0.1. What you really should be doing is revisiting your ratings and trying to think through where the inconsistency lies and see whether you need to make adjustments to your ratings. What I've done is I've diagrammed this. So let me just go around to the spreadsheet and I'll put those new numbers in there. Okay. So one way of looking at it, so this is taking the numbers directly out of the spreadsheet. Ice cream is moderately preferred over durian. This is saying that chocolate is moderately preferred over durian. And this is saying that ice cream is moderately preferred over chocolate. This is exactly, the second diagram here is exactly the same thing. So it's saying ice cream is moderately preferred over durian. Okay, ice cream, durian. Ice cream is moderately preferred over chocolate. Ice cream is moderately preferred over chocolate. And chocolate is moderately preferred over durian. And that's this relationship here. Now, what we see when we look at that is we've got a moderate preference, and here we've got a moderate preference. These two relationships are meant to be logically consistent, have a property we call transitivity, which just means that in this case, it just means that the sum of these two should be bigger than 3. Okay, so in fact, the combination of those two, so a moderate preference here and a moderate preference here, should be a fairly strong preference for ice cream over durian. Stronger than 3, stronger than moderate. Okay, they don't necessarily add up or exactly multiply or whatever, but if we accept these two, the ice cream to chocolate and the chocolate to durian, then we really need to have something at least a bit bigger here than 3. That can't just be moderate as well. So in this particular case, it would turn out if, so this is the one we're looking at changing here is ice cream to durian. So that's this one here. If we make that 4, that will fix the inconsistency. We can completely get rid of the inconsistency by making that 9, but we may, we have to use our judgment and be sensible here. This, that's a big increase. This technique has a reasonable degree of flexibility in it. It doesn't force you to be absolutely 100% brutally consistent, but it requires reasonable consistency. I generally find if I run into a consistency problem, sketching it on paper like this will often point out to me what the problem is. Okay. Now, I've got a little example here I just wanted to show you. Now, this is an application of comparative judgment that has nothing to do with decision making, and this is from that same 2008 paper by Thomas Sati. He got a bunch of people, I can't remember now whether they were meant to be experts or not, but he got them to do comparative judgments about the relative consumption of different types of beverages in the US. So he got 30 people, and he just let me get this back on the screen. Oh. You got 30 people, and he said, okay, I want each of you to do a comparative judgment matrix where your intensity scores are about your belief about how popular the consumption of these different things are compared to each other. So, and then he averaged them. And we'll look in a moment about how you do that. So we averaged the results from the 30 people. So coffee came out with a score of 9, an intensity score of 9 relative to wine. So if we go back to our, actually I've got the rating scale here. You know, so 9 would be saying that coffee is, you know, extremely more popular than wine. And what was 5 again? Moderate plus. Coffee is moderate plus more popular than tea. Only slightly more popular than beer, and the same as soda, and the same as milk, and half as popular as water. Okay, so they did all of that, and then you got actual data about the consumption of these things in the United States. And the amazing thing is they're very close. You know, this sort of little mini crowdsourced set of estimates came out very close to the real thing. Quite interesting. So you can actually use, you can use comparative judgment for various market research type things. And I mentioned earlier that I think that there's a whole sort of subdiscipline or discipline of things called discrete choice analysis and conjoint analysis, and comparative judgment is one of a bigger family of techniques. I've used a technique called adaptive comparative judgment for marking, and where it just involves the marker comparing pairs of, in the case I did it with, it was for a business plan, I think. We did the proper marking as well. We did it the regular way, but I also had a very cooperative assistant who did a large number, many pairs of comparisons, and the comparative judgment actually produced better results, more accurate marks than the regular marking technique, and it took about the same time. It was a little bit quicker. So yeah, that's quite useful. Now, let's talk about rating scales. Okay, so one of the issues with comparative judgment is the number of comparisons required. It can just take a lot of time and organization. But also, you know, some people are just going to say, you know, what is this thing that you're inflicting on me? It's too complicated and we don't have time for it. So expect to encounter that sort of response as well. So you can use rating scales, and the way you go about it is something like this. You'd have instructions for how to do the rating, and sorry, I was trying to get everything lined up on the screen here. It's not cooperating. Okay. All right, so for the example we've been looking at, you'd say there's 7 objectives. Please allocate 100 points among the objectives according to your rating of their importance for the decision. You must allocate a minimum of 1 point to each objective. So that's the minimum of 1 point is just, you know, you don't want an objective with 0 weighting. Quite often in practice, if you're talking about 100 points, you might say a minimum of 5 points or something like that. And then for the alternatives, you can do that across the rows. So you can say for each objective, you have 100 points to allocate amongst among them according to your rating of how each alternative, so each project, would contribute to the achievement of the objective. In this case, you're allowed to award 0 points. So you end up, you know, with something that looks like that. And then it's not essential, but what we commonly do is we normalize down the columns. So what that means is we typically we just turn them into percentages. So what you do is in each column you divide each number by the total for the column, and that will give you something that looks like that, and that becomes your MCDM matrix.